Hey folks, welcome back. We are into chapter 15 and we are going to do a mathematically fun example. And the physical system looks like this. We are told that it is rotating about the vector, the axis that's created by the vector between points A and E. So if you can imagine, let me just add a line here. Let's see, how about there? Okay, it is rotating about this axis, and we are told that it is rotating clockwise. So from point E, it is rotating clockwise. So let me try to draw this in. Here, it's in that direction. Okay, so according to our problem statement, well, that makes the positive direction from E to A, right? So we are asked to find the velocity and acceleration at point C, and we are given that the omega for AE is 9 radians per second. Unfortunately, what we're asked to find is in terms of IJK, and what we are given is in terms of omega, right? So we are given the angular velocity in terms of radians per second. We need it in terms of IJK. So whenever we find that, it makes sense to pretty much immediately define all the points. So let's do that. Let's find these things. All right, so A, I think we're only going to need A, C, and E, right? So let's just do those. So A is what? A is 0. Well, let's see, in the x direction, 0. In the y direction, it is 0.4. And in the z direction, it is 0.2. Okay, C is 0 in the x and 0 in the z. So 0 in the x and 0.15. And by the way, we're given the dimensions in millimeters. I'm just preemptively converting to meters because velocity is in terms of meters per second. So let's see, that is 0 in the z direction, and now E is where? E is 0.4 in the x direction, and then 0 and 0 in the y and z direction. So 0 and 0. All right. Now recall from statics, when we define a vector, we define it like this, right? So f the vector is equal to the magnitude of the vector times its unit, right? And in this case, we're given omega AE, right, which is actually a vector, AE, right? But we need it in terms of its elements, so we need the unit vector for AE, right? And that will give us the omega that we need, right? So this is the relationship that we're working with, and so what we need to find is we're given this, right? That's right there. We need the unit vector, and recall the unit vector for AE is equal to the vector AE divided by the magnitude of that vector, right? Because remember, it has to add up to 1. And so if you divide it by its total magnitude, then it has to add to 1. So we need AE, so let's get AE. AE is really just what? It's A minus E, right? So what is that? That is 0 minus 0.4, so 0. Well, let's see, 0 minus, so minus 0.4. Okay, then 0.4 minus 0, so 0.4, and then 0.2 minus 0, so 0.2. And note, I could write this in the ijk format, right? So it would look like this. It would be equals minus 0.4i plus 0.4j plus 0.2k, right? And if this is easier, then use this method. For me, I'm just as happy to write a little bit less. So, okay, so what do we need? We need the magnitude. So AE is equal to, that's Pythagorean, right? So let's see, 0.4 minus 0.4 squared plus 0.4 squared plus 0.2 squared. And we want the square root of that, which just happens to be 0.6. Okay, so when we divide this, so what are we going to get? We're going to get this. So AE equals, so 0.4 divided by 0.6, that's 2/3. 2/3 again, 1/3 there. And I'd rather not write a bunch of 3s, so let's say 1/3 times, and let's go ahead and put this in long form, why not? So minus 2i plus 2j plus k, right? And that is my unit vector. Cool. So now I can get omega by just multiplying this times omega AE, which is 9, right? So omega AE, so if I multiply this times 9, then I get 3. So 3 times negative 2 is negative 6. So negative 6i plus 6j plus 3k is my rotation vector, and that is not WAE, that is, or excuse me, omega AE, that is just omega. Alright, okay, so now what? Well, recall from the last video that when we want to calculate this, we need this RP right here, right, and where omega is going around like this, and we find V equals omega cross RP, right, where this was RP. So now we need RCE, right? So this would be point C, and this is point E, right? So again, C minus E. So RCE is, let's see, 0 minus 0.4 equals minus 0.4i plus 0.15 minus 0 is 0.15, so 0.15j, and there is no k component. Okay, so now we just cross them, right? Okay, so let's see. We'll do it here. We'll say V equals omega cross RCE. Okay, and we have I and then omega, so minus 6, and then the I component of RCE is minus 0.4, then J, we have 6 and 0.15, K, we have 3 and 0. And then recall from linear algebra, if you've taken it, that the straight up and down bars actually mean the determinant, which is what we're after. So let's blast through this. So the I direction, what do we have? We have 6. So 6 times 0 is 0, minus 3 times 0.15 is 0.45. Okay, then minus in the j direction, we have minus 6 times 0 is 0, 0 minus, and then minus 0.4 is plus, and then that is 2.4. Okay, and then plus k direction, we have minus 6 times 0.15, let's see, minus 6 times 0.15 is 0.9, so minus 0.9, and then minus, and minus and minus is plus, so 2.4. Okay, so what does that give us? That gives us minus 0.45i minus 2.4j, and then 2.4 minus 0.9 is plus 1.5, so plus 1.5k, and I feel like that number should be smaller. Let's see what I did wrong. Let's see. So in the j direction, oh, I multiplied 0.4 times 6. I should have multiplied it times 3, so this is 1.2. Alright, 1.2, 1.2, that feels right. 1.2. And minus minus that. Okay, so this is V. This is a solution. One of the ones that we're after. Okay, now recall from the last video that A is equal to alpha cross R plus omega cross V, right? In this problem we're given that alpha is 0, so this component is 0, but we need this, so we need to cross this again. Alright, so come over here, we still have some room. And so what are we doing? We're doing omega cross V. And so in the I direction, omega is minus 6, V is minus 0.45. In the j direction, omega is still 6. This is minus 1.2. In the k direction, this is 3. And this is 1.5. Okay, so I, what do we have? We have 6 times 1.5 is 9, minus, and minus times a minus, and that is minus 3 times 1.2, it's plus 3.6. Okay, and then minus j. And that's minus 6 times 1.5, and that is minus 9, minus, in the j direction, so minus times a minus is a plus, 3 times 0.45, I want to say 1.15, but 0.45, let's make sure, 1.35, there we go, 1.35. 3.5, and then in the k direction, oops, a little antsy there. In the k direction, we have minus 6 times minus 1.2. Let's see, 6 and 1.2 is 7.2. So minus times a minus is a plus. So 7.2 minus minus times a minus is a plus. 6 times 0.45 sounds like 2.7, so 6 times 0.45, 2.7, okay. Okay, and what does that give us? That gives us 12.6i, let's see, minus 9, 1.35, so 9 minus 1.35, 7.65, so this is minus 7.65 times that, so plus 7.65j, and then plus 9.9k. Okay, and now that is our answer actually. So A equals this. So it saves a few steps when there's no acceleration component. Saves one more equation. So that wasn't so bad. Maybe that wasn't so ugly. All right, well, I hope that was helpful, and I will see you in the next video.